Many people believe that a small p-value directly tells us the probability that a research hypothesis is true, or even that the null hypothesis is false. It is a frequent point of misunderstanding in statistical analysis. You might wonder if a low p-value proves your hypothesis is correct, or if a high one means it is wrong. To address this common question directly, no, a p-value does not determine the null hypothesis truth. Instead, a p-value measures the strength of evidence against the null hypothesis, given that the null hypothesis is actually true. It is a conditional probability, specifically the probability of observing data as extreme as, or more extreme than, your current results if the null hypothesis holds true. The core mechanism behind this distinction lies in what the p-value actually represents. It does not tell you the probability that the null hypothesis is true, nor does it tell you the probability that your alternative hypothesis is true. Think of it this way. If the null hypothesis were true, and you repeated your experiment many times, how often would you get results as unusual as the ones you observed? A small p-value simply suggests that your observed data is surprising under the assumption that the null hypothesis is true. It is a reflection of the data's consistency with the null model, not a statement about the null model's inherent truth. So, how should you interpret and use p-values? When you conduct a hypothesis test and calculate a p-value, you are essentially asking if your observed data is likely to occur by chance if there is no real effect or difference. If your p-value falls below a predetermined significance level, often alpha of 5%, you would typically reject the null hypothesis. This rejection means you have found sufficient statistical evidence to suggest that the null hypothesis is probably not the best explanation for your data. However, it does not confirm the truth of your alternative hypothesis, nor does it definitively prove the null hypothesis is false. It is merely a decision rule based on observed data. It is also crucial to distinguish between statistical significance and practical significance. A very small p-value might indicate a statistically significant result, meaning the observed effect is unlikely due to random chance alone. However, this does not automatically imply the effect is large or important in a real-world context. For instance, a drug might show a statistically significant but clinically insignificant improvement. Always consider the effect size, which quantifies the magnitude of the observed effect, alongside the p-value. The p-value simply tells you about the rarity of your data under the null, while effect size tells you about the size of the difference or relationship. Understanding that a p-value quantifies the evidence against the null hypothesis, rather than its truth, is fundamental for sound statistical reasoning. It helps you avoid overstating your findings and encourages a more nuanced interpretation of research results. By integrating p-values with context, effect sizes, and other forms of evidence, you can make more informed decisions and draw more accurate conclusions in your studies, enhancing the reliability and impact of your work.